Okay, cool. So we're good to go? I just unmuted. I just did the unmute. Okay. One, two, one, two. Everybody, you can keep talking. Don't worry about it. We're just testing the mic out. One, two, one, two. Can I hear it? We'll have to do this. We'll have to sing a little note song. Jazz it up a little bit.
Do you have a HDMI hookup?
No.
Oh, so you can use this.
Okay, cool, cool. For the HDMI? Oh, for the recording.
Well, I mean, to share your screen to that, or you have slides or code?
Yeah, I saw
Yeah.
it. Right, right. Okay, we are going to allow Apple so secure.
All right. For the first, because I'm going to use your laptop.
Oh, yeah.
Can we open the meetup page?
Okay, cool.
Why do you see this?
Oh,
Hey,
right.
why does he see who's waiting in the waiting room? Isn't there an option for you to give them sharing permission? Because otherwise he's gonna get hit with that each time. All right, in the meantime, well, dang. Okay, let's do this. Oh, you have each one set up? Okay. See. How do you get to the meetup page? I was like, oh, it's set on
yeah, we're gonna get out of here. I was yeah. Squeeze out on now. Okay, cool.
yeah, just share the meetup image. Yeah. Just open that image. Actually scroll down for the high res one. I don't know why meetup does that. It's driving me nuts. Like that one is more high res.
Okay, cool.
Well, not that one.
Oh yeah, go,
that one.
That one. Okay.
So if we could just make that full screen for a moment.
Yeah, for sure.
If you press control and then click on that, let you open the image in a new screen.
Oh, so I probably have to do like a split screen.
Not even that. But if you just do now, click on the image.
Okay.
Open image in new tab.
Okay.
And now let's just go to the image.
And then just go straight there. Yeah.
Yeah.
Okay, cool.
That'll do that right there for us.
Look, great.
If it'll click it.
Look, it's not even clicking.
There you go.
There we go. Okay.
That's fine.
Okay, cool.
And then
and then I'll just switch over to the response.
All right. Let me do a little intro. Are you fine with David Key or do you want David Key from Texas?
Okay. Oh, share the screen in Zoom.
Oh, okay.
Okay. Yeah.
Host disable participant sharing. Interesting. Okay. There's people in the waiting room. Yeah, I'll just do that.
Okay, cool.
Why are we so dark on that screen?
Yep. Your mic.
Are we unmuted? All right. It's a clap for the third speaker. What's going on, y'all? Hey, we're finally started. What's going on? For those online, you can't see this. This room is packed, y'all. I'm so proud of this. Everybody, I'm Danny Thompson. Welcome to A Night of Java. Thank you so much for being a part of this. Online attendees, thank you for hanging out with us. You could be anywhere in the world right now. You decided to hang out with us. That means a lot to me. Wherever you are in the world, you're an honorary Dallas citizen for the night. So, enjoy that, enjoy that. For those of you that don't know, this is a Dallas software developer meetup. We do meetups every 2 weeks. We just did a meetup 2 weeks ago. That was a pretty big success as far as I'm concerned. We're doing another one tonight. We have another meetup signed up for 2 weeks from now. Shout out to that one in particular. We're doing something different. We haven't done this meetup before, and it's following a different concept that's called open spaces. Essentially, there's no predetermined amount of speakers that are allowed to be here. Anyone can essentially be a speaker for that one. And the idea is we're going to be setting up little sections around the room, and anyone can basically choose a topic that they want to speak about. People can attend that talk. It's much more intimate, smaller groups. You can ask further questions. You can see demos. It could be technical or soft skill related. If that's something that you're interested in, whether you've spoken before, or maybe it's the first time you're ever speaking before, we would love to have you be a part of that. Actually, I got the idea for that. Shout out to them as well. That conference, I went to that conference last month, and this was like a wild success. I learned so much about so many different topics from speakers that may have never spoken at an event before. So it's really, really cool to be a part of that. If you have anything that you'd like to share, it's pretty low pressure since it's not, maybe a big room and maybe you find it intimidating. Really great way to kind of connect with the community. Other shout out I want to give, we have a star-studded group of speakers with us tonight, kind of covering that up, but I can't move that. One speaker in particular I want to give a shout out to, Lawrence Lockhart. That's my brother, man. He flew in for this talk. So big shout out to Lawrence. Lawrence and his company Vaadin, big shout out to Vaadin for allowing him to be a part of this. Fun fact, he's actually the reason why I ever went to my very first meetup ever. And so for him, he holds a very, very big special place in my heart. If it wasn't for him, I don't even know if we'd be hosting meetups to this day. It's been, over 5 years we've been hosting meetups now because of this. So big shout out to Lawrence for being here. Of course, the other speakers, big, place in my heart as well. Your commute was 30 minutes, but still, give him a little credit for flying in. But with that being said, big shout outs to our sponsors that even make these events possible. We don't monetize our events in any way, shape, or form, right? So our sponsors are literally young brands. The building that we're in, they allow us to kind of do our meetups here. So big shout out to Young Brand. Please round of applause for them. Make sure to hear that one. Second big shout out is to AppRight. They're the ones that paid for the pizza, the drinks. That's it, right? So we don't really take checks. We don't try to monetize this. We're completely volunteer ran. So the volunteers that even make these events possible are in the room right now. We have Clint in the back, Clint right there at the table. We have, everybody see? Yeah, Wick. Clint's been doing meetups for years now. We also have Dennis Garcia right here in the front. Yep. We've got Eric Anderson over here, Eric. We've got a couple other people that help us out that aren't here tonight, but they're here with us in spirit. They're always active in the Discord channels and the Facebook groups and all that other good stuff. So huge shout out to them as well. One extra shout out for AppRight. They have a thing that they're doing called Init, which is starting next week. It's like 5 days of feature releases and speakers. For those that don't know, AppRight, it's a backend as a service tool. They do database management, they do authentication, all the good stuff. It's completely open source as well. So if you're trying to get into open source, they have a bunch of commits that you can be a part of. Very, very active Discord channel. Big shout outs to AppRight. They're the reason why we're able to kind of extend our efforts the way that we do, because before we had them as partners, we were literally chasing after a pizza sponsor for every event. Thankfully, for the last 6 months, we haven't had to do that once. So big shout out to them. Now, the one big announcement, some of y'all may be aware of this, some of y'all not. Once I came in the room, I was asked about it multiple times already. We do cohorts, okay? We do completely free cohorts as part of our Dallas Software Developer Group. Basically, the idea is we get a bunch of, they're a little bit past the beginner stage, but beginners nonetheless. Could be people that are either early in their career or trying to get their first jobs in tech. And for 6 weeks, we put them on a team where they're
basically making projects with a seasoned software developer guiding them essentially. Of course, it is completely volunteer ran. We've had multiple people land their first jobs in tech because of that cohort or the experience that they had in that cohort. We've had very, very big success with these cohorts. We don't monetize it in any way, shape, or form. If you would like to be a leader in this, whether meaning you're a software developer that wants to kind of give back to the community, it's a 6-week commitment, 2 calls a week. If that's something that you're interested in, I would love to have a conversation with you. I know I've had multiple people already reach out to me, but I would still like to extend it because the more leaders that we have a part of it, the more students we can essentially help in that 6-week process. And last year, I think we did 7 cohorts. We want to kind of be on trend to do something similar again. If that's something you're interested in, please don't hesitate to reach out to me. If you're local in the Dallas area, please, if you're not in the Discord, highly recommend checking it out. We have a very, very active Discord with a bunch of local developers in there. We do all of our announcements in there as well for our meetups. We also do some online events as well that are kind of in there. We're going to be doing a lot more of that this year with social hours and office hours and things like that. Would highly recommend you being a part of that as well. The last kind of announcement that I want to do before we get the speakers up here, if you are in this room and you want to give a talk on something, don't hesitate to reach out. We love doing these Night of Javas, Night of JavaScript, Night of C#, which is coming up, Night of UI UX, which is also coming up, Night of Mobile Development, which is also coming up, Night of Cloud. Basically, for us, these are mini conferences for the community. We don't monetize it. We get speakers. Anybody that's eager to talk about a subject, we'd love to have them. So even tonight, some of the speakers are speaking for their very first time. Some are very seasoned and they are very experienced. We keep the format pretty engaging for the most part, I believe. And the ultimate goal is you may not necessarily walk away with a massive amount of technical knowledge from one session, but you may be curious enough to research that topic once you get home and start diving deep. And hopefully we can help facilitate that in some way, shape, or form. So be on the lookout for those night ofs. We basically do it for the community. And so if you want to be a speaker in that, we'd love to talk to you as well. Outside of that, I think I've kind of spoken quite a bit now. If you need to reach out to me, I'm active in the Discord, especially for our Dallas Software Developer Discord. Highly recommend checking that out. You can go to DallasSoftwareDeveloper.org and you can get all the links to our stuff. But outside of that, I want to introduce our first speaker tonight. This person in particular, I've seen him grow tremendously within this last year alone. And I don't think he knew I was going to say that, but I really have. In the last year alone, he's grown tremendously. David Kia is going to be giving our first talk tonight. And the floor is yours, sir.
All right. Let's see. Let's move this kind of. There we go. Let's get that down here somewhere. Okay, sweet. Okay, good evening, everyone. How you doing today? Awesome, awesome. So just before we start, I don't have a lot of time, but Danny did ask me to, anything I want to talk about Java. And so the first initial thought was coffee. So you may be disappointed to hear for coding, okay? Just so you know. That's a bad coding joke. Let's just get to it. So right now, okay, we're going to go through the 4 pillars of object-oriented programming with Java. So if you've never heard of Java and you don't understand anything that's about to happen after me, good luck, okay? But just try your best to catch on. I hope that I can break this down enough to you so then that way you can kind of get your feet wet with Java. So before I get going, if you have your phone and your camera, please, let's connect. That's going to go to a link tree for me, and that's going to connect with LinkedIn and Twitter. I love friends. Don't we all love friends? All right. Okay, so the 4 pillars of object-oriented. So the first one we're going to start out with is abstraction. And a lot of you know this already. You did this as kids. especially when you had your favorite toy, favorite food, whatever, you tried to hide it from people. And that's abstraction. We are literally taking those internal details and just showing what's required where we're hiding. In other words, take for instance, whatever you have. You may have your cell phone. The things that you see as a user are your buttons, maybe 2 or 3. Everything else you don't see. They're only going to show you what's required for you to be able to use it, and that is it. That is abstraction. We're just showing the users what they need to do to get the job done, and that is it. Encapsulation. Now in Java, you're dealing with classes, and those classes are real-world objects. So for instance, let me give you an example of a human being. Now, what would be some attributes? Maybe some eyes. Yeah, if they're bald or not. Then name, right? Those things, those are the attributes. So we're going to build out the class with those attributes. Now, we have to make those attributes active. Now, in order to do so, because you're going to see examples later, we put them in constructors. And those constructors help to activate those attributes so we can use them later on in the program. But also, as humans, we do certain things like what? Wake up, wash, brush our teeth, we walk, dance, argue, fight, whatever. Those are the methods, the things that you want your objects to do. And all those things encompass your class. So that's an example of encapsulation. Inheritance. Now, I'm assuming everyone here was born from 2 parents. And because of that, as a result, you have inherited characteristics from both of those parents. And in Java, just like that, you have a parent class, and then you have the child class. Or the parent class is also called the super class. And then in the child class, that's the subclass. So when you start hearing these terms where people say super class, at first I thought it was just some magnificent class that was not involved with the program. I was like, super class thing. Super class. You keep talking about super class, super class. Only to find out it's the parent class. That's it. So now you know inheritance. And with that, you end up reusing the properties from the parent class to be used in your subclass or your child class. And we'll see that as well. Polymorphism. It's a concept where you take a single operation and you have different ways of basically enacting an action, right? So for instance, let's think of TVs, generalization, right? Sony has a TV, LG has a TV, Philips has a TV, correct? But when you look at them, the design of them, although they operate similarly, they have distinct characteristics. One may have a button or power button on the bottom of it. One may have the one on the top. One may have it on the back. It's still a TV, but it's a different way, another way of using the same operation or single operation. So here we have our circle class. And I wanted to keep this as simple as possible just so you can digest what's being basically presented to you. And so in our circle class, our parent class, we have what we call an attribute or a field, because you may hear that term too, private double radius. Now, the thing is, we want to protect the information within our class because we don't want anyone to really change it. So what you do is you make your fields or your attributes private, so then that way they're only accessed within that class. Why is that important? Well, I don't know. Anyone have any kind of like quirks where they like to put things where they like it and they don't want anybody to mess with it? It's the same exact way. You may develop something, you're like, look, I don't really want nobody to just mess with this and change it. It works. Anybody ever mess with broken code and try to fix it? Yeah, it's not fun. Because now you're redoing it pretty much in a lot of cases. So next we have those constructors, right? Because we have to activate that field, that radius field. So then we activate it with this dot radius equals radius. So that this dot radius is pointing to that parameter double radius in parentheses is pointing to that radius attribute and saying, okay, it equals radius. Pretty redundant, right? We know that. Now we have methods. We wanted to do something. So we say, okay, public double get area, just standard stuff for a circle, return radius times math dot pi. Now here's our first example, one of those pillars. Well, not really, kind of like a little second example, but polymorphism. Because now I have another method that is the exact same thing as the one before that. But what's the difference? The difference is inside of the second one, there's a double radius. This allows us to make the changes we need to make for this particular method to overload. So that's what it's called, overloading. It's the same name, but now the only difference is you're adding a parameter or maybe more to accomplish something a little bit different within your code. And then next we have a public double get parameter, just another method. It's not an overloaded method, but we'll see in the next example. Now we have our cylinder class. And because you can't see that bar, oh my goodness. Yeah. Okay, I'm gonna leave it there. Okay, so the cylinder class extends circle. So that's how your child class acts. It extends the circle. Or basically, hey, I'm gonna bring in characteristics from circle, whatever that is. So now we have private double height because it has its own field. And then we have public cylinder double radius, double height. So it has two parameters, but I want you to notice something right underneath that. It has super radius. Remember I talked about the parent being super? We're calling that radius attribute from the parent class. And now we're just going to instantiate the height with this dot height equals height. So now we have a method to get the volume. Oops, now we run into polymorphism again. But we're not overloading this time. We're overriding something. And what are we overriding? Well, in our parent class, we had to get parameter method. We're going to take that method and we don't want it to use the same calculation. We're going to say, hey, return 20. Just do that. So we're going to override that method. And what we get in the example, I know it looks all crazy here, right? Freaking somebody out and say, what is this stuff? In our main method, public class main, we have to print this stuff out. So what you're going to see is public static void main. That's just standard. You probably seen the hello world and you start coding. You're like, yeah. Public is the assessor. That's going to allow all the classes to be able to access this main file. Static is staying where it is. It's not changing. Void doesn't return anything. Main string args. It's just going to print out a string of arguments. Those arguments are everything down here because as you see in circle, I have to now create that object. And in Java, in order to create that object, you have to make it new. That's how you create an object. You first take the class name, which is the capital C. You give it a name, small circle, equals new circle. And then I want you to notice the numbers afterward because that is the radius, right? But also for cylinder, it has 2 and 5. That's the radius and the height. So that's going to be calculated, and what we end up getting in the end is our answers through the calculations, but also we see that that parameter is 20, so that was an override, and we see that our results of that code was how we wanted it. So that was just a short example of the 4 pillars, and I want you to remember the 4 pillars is A, E, I, P. If you're around kids, they're going to crack up because they're going to realize the last 2 letters. But don't worry about it. Abstraction. So we want to conceal something. We only want to show what's required. Encapsulation. Our class has to have the attributes. It has to have a constructor. It has to have methods in order to be a fully functional class like we want it to do. Then we have inheritance. That means that our child classes will inherit properties from our parent class. And then polymorphism, it's basically generalization, a single operation, many different ways. Any questions? Thank you for your time.
All right, we're gonna bring up our next speaker, Akshay. Go ahead.
Correct. Fine. Good evening, everyone. Good evening. Yeah. My name is Akshay. I'm a senior software engineer with Securonix, and I'm going to here to talk about a bit about Kafka. Before I talk about that, Java runs on over 60 billion devices, and that means that a lot of devices run on the servers, and one of the frameworks that you need to do to run on servers is having a distributed architecture, which means the ability to process millions and millions of records in a simultaneous concurrent fashion. So before I talk about Kafka, let me introduce what Kafka is. Apache Kafka was an open source distributed event streaming platform that was designed for high throughput, fault tolerancy to handle real data streams. So this is a lot of verbiage over there. I'll get into it, but the essential thing is it helps us to process data in real time. And no wonder this was developed at LinkedIn, and later it was open source, and a lot of companies have started using it. You talk to any company that does real-time data processing or has some kind of a fashion where they have a lot of data to work with, they'll be using Kafka in some way or the other fashion. So if you look at the definition, it talks about event streaming. What exactly is event streaming? You can think about event as a record of something happened. So all of us coming over here, hitting up RSVPs on Meetup, that is an event that each of us are triggering from our phone, and which means that that's a notification, that's an activity being triggered, and this activity or an event is something of an interest to the company or people who are consuming these analytics. So if you had to put it into a human perspective, you can think about event streaming as equivalent to your central nervous system. There's something or the other always constantly happening in your body, even without you knowing about it. And so the point is, the event streaming can be summarized as a sequence of events happening in a snapshot of time. So collection of all the streams or all these time-bounded events and being able to consume is pretty much what an event stream is. So now that we understand the modern day and how there's so many events or so much of data being produced, how does Kafka come into the picture over here? What does Kafka do, and why a technology like Kafka exists? as we talked about, we have so much of data in this world and so much of different sources on which data exists. And Kafka gives you an ability to pull in data in a very high throughput fashion, which means that you are able to consume messages at a rate of scale and be able to process them at a rate of scale as well. Decoupling data producers and consumers. I'll talk about producers and consumers in a bit, but the interesting key point to take over here is it's decoupled, meaning your producers are independent of your consumers, which means that if you are like, similar to the RSVP where you sign up, people are signing up all over the place. Some people sign up in the morning, some people sign up in the evening, but the bound of data is always continuously flowing into the system, which is the backend of Meetup. So you also have scalability and fault tolerance. So think about this. Hundreds of users, a typical system can handle. Millions of users, it might still be able to handle. What about billions of events? That's the rate at which events are created every single day. And you need a system to be able to handle this level of scale, but also be fault tolerant, such that if something fails, we still need it to be working. So event sourcing and stream processing is something I'll get into, which is a common trend a lot of companies are picking up in the recent times. And I will also talk about a couple of use cases over there. And interoperability is also like I touched about, is being able to pull data from different sources, your databases, your servers, your VPNs, your on-device analytics, any kind of a place where data can be created from. So let's talk about couple of use cases where event streaming is usually used. Real-time analytics. Imagine you're watching on Netflix. Netflix, you consume so much of event data as to how users are watching, the user behaviors, their preferences, and try to do real-time analytics as to it, which can be the number of times a show has been watched, number of times a show has been liked, so on and so forth. Fraud detection. A lot of banks like JPMC use Kafka in real time to detect a lot of fraud, and also a lot of your e-commerce store will use Kafka to determine fraud in a real-time scenarios. Because of the scale at which e-commerce websites operate on, they need platforms like Kafka to enable this kind of a workflow. And log aggregation and monitoring is pretty much all the devices connected on a network generate an event or an activity, and we want to be able to aggregate this to determine system health, user activity, and all the above. I mean, e-commerce, supply chain, social media, a couple of the other key areas where Kafka is widely used. So you just think about anywhere you think about scale, Kafka can be a distributed platform that you can work with. Let's talk about a couple of Kafka jargons, as I talked about producers. Producers can be or any device from which an unique data is generated. Clicking on a website, that's an event produced on that. So that your click on the website acts as a producer. Then you have consumers. Consumers is pretty much where you consume data from. So it can be any of the places you want to consume all the clicks that happen from a database. You want to consume all the data sitting in a database. So you typically start a consumer to consuming from the data. And topic. This is what helps Kafka be distributed and be decoupled. So topic is a collection of, you can think of topic as a collection of records, which are more of an immutable log, which only works in an append-only fashion. Again, a lot of words. What it means is that you can think of it the best abstracted way as a file, and you keep adding new entries to the file, so on and so forth. And the way you do is you segregate your files into partitions, which can be think of it like file 1, file 2, file 3, and file 100. And being able to consume all of them at once is something that Kafka does. So if you take a look at the graphic over here, you can see an abstraction provided by Kafka, which is topic. And you have P1, P2, P3, and P4, which are partitions. Usually, your partitions are the data that you write to a partition are usually separated by a key value pair, and you consume in a similar fashion. So now let's talk about what Kafka Streams API does and why is this technology so in demand right now. So one of the things that companies nowadays want to do is analyze the streams in real time. So you have hundreds of clicks happening on a website, and you want to be able to see who is clicking on what and what this activity is in a real-time scenario. That's where frameworks like Kafka Streams comes in, which gives you the ability to monitor the streams in real time. So like any API, it's an abstraction already built on top of Kafka, and it gives you the ability to process your stream in real time while also managing application state. So a couple of key highlights it does is it's a pretty lightweight library, and you can use it with Spring Boot, you can use it in a native fashion, you can use it with a different variety of Java frameworks out there. And the best way is it gives you two ways of access, high streams DSL and low-level processor API. A high streams DSL, you can think of DSL as domain-specific language. It is where you just want the analytics out of it, whereas a processor API is where you want more finer control on it. So let's talk about the topology. I will not touch more into topology just because it can be a bit complex to get into. But the point of a topology is you having the control on where your data starts from and where your data ends to. So you having the ability to determine your source, and you have the ability to determine your sink. The source will be where you consume your data from, and sink will be where you write whatever is changed in your thing. And in terms of Kafka streams, a stream is an unbounded abstraction provided by Kafka that gives you the ability to manipulate them in a real time. So again, one more graphic, but the point that you need to look at is you have some source that you keep getting data from, you have some source to which you write data to. In between, you have your consumers, like I talked about, which are lightweight Java applications which consume and write to. So that's a pretty good abstraction about it. So let's just get to the code. I will try to be brief about it, but this is a typical way how you'll work with Kafka streams. I would like to show you how really easy it is to get started with streams. I mean, if you have worked with Spring Boot in the past, this is pretty much a configuration file where you can define your configurations and pull in your configurations. And this is pretty much normal that you will do. So once you define your configs, which are nothing much your bootstrap servers or like where your brokers are, and after that, you can do is take these properties and start your define your topology. So the topology is something that I showed you about is this diagram. So what we're trying to do is implement this diagram to help us do it. So nothing fancy over here. The key thing is we load the properties that we have defined, and then we define an instance of stream builder in which we would be specifying the input topic is our source or wherever you want to consume your logs from. Then after that, a state store is something very interesting. I'll get to in a bit. And after that, we would define a processor. So processor is our business logic where we do what do you want to do on this data? So do you want to add, do you want to subtract, or any kind of business logic that you want to do? And after that, you just do a stream.start and your stream is up and running. So let's look into one of the stream processor at what it does. I mean, if you look at this example, it's pretty basic. So you see a process method where you're getting a key and a value. Like I talked about, Kafka gets key and a value pairs. So all I'm doing over here is as the words come in, I'm making a counter of number of words that come in, and that's putting it into a database. And the beauty about this is you can put them in your store or your database and be able to query them in real time, which is really, really cool, which means that you don't have to define a database. You don't have to create one more database where you need to push into, and you can have access to your stream on to what it is. So to talk about what exactly is happening over here is you have the ability to query your data in real time instead of your data going to a database. That's how much of abstraction that Kafka really provides. So that's the coding of it. Let me talk to you about a real world scenario at how at Securonix we use Kafka streams. So this is a product that I have developed last quarter, and this is something really, really cool that a lot of customers want to see. Being in a cybersecurity space, one of the key things that customers want to be able to do is monitor what is happening on the network. And in cybersecurity space, you run something known as event management, being able to collect data from a wide variety of sources, your VPNs, your on-screen devices, your laptops, your devices on network, your printers, and all these devices, and be able to monitor them in real time. So monitor them can be like different things. Is the device still on? Is the device, when was the last time the device sent out a notification? Or any of those complex basic analytics that you want to do. So our customers came to us and said that, hey, we want to see all the devices on the network. And using that, we were able to, since we already had a lot of framework already developed, where we get the data and ingest the data, we were able to convert this stream of data coming in into an inventory where we uniquely keep track of all the devices on the network. And this is such a beautiful abstraction because I'll tell you the performance numbers. On a 4x large machine, which since we use AWS, that's a 30-core machine and a 120 gig RAM. Sorry, 16 core and 120 gig RAM. On that machine, in a single day, we are able to process 10 billion events without even doing any kind of horizontal scaling. And this is defined by the parallelism that Kafka gives. And the way it does it is you define the number of threads, which is your concurrency that you define. But the point is, anywhere that you go where you want to consume any kind of real-time analytics, Kafka is the go-to choice just because how widely it's ever adopted and how easy the functional APIs are. So that's a real world use case that I wanted to picture. So for you to understand how Kafka really helps at scale. And that's pretty much the talk about. And if you guys want to connect with me, this is my LinkedIn. I'll be very happy if you can connect with me. Thank you so much.
Thank you very much. Thank you very much. Say right now that thanks to David's intro, I really understand some of that stuff. So I don't know Java, but I'm kind of starting to get now. Thank you, Akshay.
Thank you.
All right, next presenter, we're going to introduce her, Priyanka. He's not. Okay.
Yeah, thank you. Good evening. I'm Priyanka Koppula. I work at JPMorgan Chase as a senior software engineer. Before I get started into my very technical PowerPoint presentation, I just wanted to kind of level set everyone's expectations on what microservices are, especially if you're new to Java, if you're new to microservices overall. So I brought my Django box here. So to give you an overall idea of what I'm talking about today is how the industry standard is usually a monolithic approach, and we're migrating from that to microservices. So what does that mean? What are the benefits of either one? And how can we convert from monolith to microservices? Is going to be what I'm going to be presenting today. Before I get started, if you can you talk closer to the computer? That's what. All right. Okay, is this good? Yeah, okay. So as you can see on the chair, I don't know if you guys can see it on Zoom, but there are three structures of Jenga. The tallest one represents a monolithic structure. And if I were to ask any of you to like poke out one of those lower level blocks, what is the most common, what's gonna happen? most likely it's gonna topple over, might fall, half of it might be standing, and you just don't know what to do. Microservices are the tiny three ones. So if you stack those three, they should make that giant monolith that you see. So microservices are basically you take that giant structure, make it into smaller ones, and now if I were to poke a block out of any of those, the structure will still be standing. My application will still be working, and everything will be running smoothly. So that's kind of the appeal of microservices as a whole. And now we can get into like the technical side of it with this presentation. So what are monolithic applications? As you see, it's a single unit. Everything that you have coded, you program, whatever your application does is in one single structure and one unit. It will be deployed as one unit, as a single jar or WAR file, and everything that you do will be inside of that. It's
Good, sorry, you stop share and then share, your screen is paused, it says. We're not seeing the screen.
okay.
Or resume share, yeah, play button screen. Right above the, resume share.
Yeah, I think we need to switch to that.
That's not happening.
Stop share and share.
Okay, let's. Okay. Cool. Okay. Lost my train of thought, but that's okay. So monolithics are very tightly coupled. All the functions are feeding into each other. It's hard to take away from it. So everything is working together as one unit. And that's basically what monolithic structures are. Oops. And now microservice, they're a little less tightly coupled. That means a lot of the functions are separated out. As you've seen over here, you take big chunks of the monolith, you can put them into smaller pieces. Each individual thing has its own functionality and it's deployed separately to your space. So you can individually work on different components of your application at any given time, add new features, change things, and it's completely separate from other functions that you have. It's typically run in Java Spring, it's typically run in Spring Boot or Java EE. The big key differences between the two of them, like why do industry people still use monolithic structures or why do different industry move towards microservices? Let's start with monolithic ones. Monolithic is pretty simple to start. It's also low cost to start. If I have an idea, I can start building right away. I can start implementing whatever I have envisioned. And as I'm implementing it, I will realize that, oh, I need this other thing for my function to be built out. And I can just add it on the fly and keep going and not stop with my vision and I'll be good. And then it's great also for performance in the sense that everything that I'm coding is in one unit. I don't have to worry about my particular application needing to reach out to some other application to get more information. I don't have to worry about waiting to hear back from some other location information because everything is in my specific code repo. And the benefit of that also is that if I need to debug anything, everything is in my repo. If something breaks, I can just hit a control find and find that error and know where exactly I need to make the fix wherever I need to, provided you do good logging. Very important, always do good logging. Microservices are all individual components. So it's based on functionality. So I don't have to go through my entire monolithic application to find what I'm looking for to see where I need to fix things. I know that within this particular microservice, it does this function. And if I have an error, I know this particular microservice is creating that error and I can debug in that way as well. Also, microservices are easier to scale. If I need more, say I have like an application like that's a shopping website and I know more people are going to hit it. So I need more of the web page to be active. I can scale my specific components quicker, faster, what I need. With monolith, I have to scale the entire application, even though I don't need all of those parts. I just need a specific part. So for microservice, it's scalable, it's easier to maintain. And if it's also different components of your microservice don't have to use the same tech stack. I can code in Java for one piece, code in like Ruby, I can code in like UI language for different components of microservice. They're independent of each other, so they don't need to be the same language at any given moment. So that makes it easy to push out features either on the front end, on the back end, or wherever you need it, and keeps you agile in terms of how you want to push your application. And finally, it has fault tolerance. If I have a web page and say like my database is down for getting user information, if I go to that web page and I hit profile, only my profile section is broken. If this was monolith and one section is broken, all of it would come down. This allows for the ability to have kind of fault tolerance because you don't have to worry too much about the entire application coming down for one specific part of your application. Next, how do you choose between the two? It's really based on your use case. If you have a pretty simplistic application, you can get away with using monolithic structures because it's one simple location of everything, easy to debug wherever I want. The downside is the more complex your design gets, the more people you would need to maintain it, and it gets harder to debug between the different components of a monolithic structure. So if your application is more complex in design and you have the ability to have more developers and your application is of giant size and you have to have the need for scaling, then you pivot towards using microservices over monolithic structures. Now, a lot of industry code, legacy code, as you call it, is in a monolithic structure because people just want to hit the ground running. They want to build on top of whatever they have, and keep on going and don't look back. I know there's a huge pivot into going into microservices. So you're here for how do I convert my monolithic structure into a microservice? These are the 8 steps in doing so. We'll kind of touch base on all of it, so you don't have to read this entire slide while I'm talking to you. We'll go through each individual steps. So the first one is identify the components. So every monolithic structure, you know what different sections of your code does. Identify what they are. Identify what could be a module and what are the individual components so you can visualize where you will need to have to make that break. Next, flatten and refactor those components. See if there's any duplicate in functionality. You might end up calling the database the same way in 4 different locations under 4 different functions. You could flatten that into one simple call, or you're calling the same exact function with 2 different data types. And you can also factor that, flatten it, rework your code where you need to, and make sure that everything is still compatible with each other. So there will be some refactoring that needs to be done in your code to make sure it's still sustainable in the functionality that you're looking for. So merge any components where it's needed. And also sometimes when you're trying to break down the structures, you notice there's just dead code. No one ever reaches this code. They had an idea at one point and no one touches it. Remove that. We don't need it. Next, identify dependencies between components. We want to make sure that we are aware of how different components work with each other so that we maintain those connections when we eventually split them, or we might even combine them into a larger group. We want to make sure that we don't disrupt existing functionality that connects to each other, because if you break one function that connects to one that's very specifically tightly coupled for a reason, you'll break the flow and your application will go down. That brings me to components group identification. Once all the modules and dependencies are identified, you focus on obviously the grouping of the components that ideally make the function or the service that you're looking for. So it's like these 3 pieces help give you a user profile. So I'm going to group these as a user profile component. And these 4 are related to UI code. Let me group that together as UI code. So you kind of identify what natural groups that all these modules kind of fall in based on different dependencies as well. This is a little bit more complex. You want to create an API for remote user interface. What this pretty much means is your user, this is the key output from this whole effort. Your user will come in to your application and they should be able to go to every component, add, remove, whatever needs to, whatever data manipulation that needs to be done with a seamless experience. you wanna, as microservice, you wanna be able to handle all of the data manipulations, all of the data information inside an API. So when you start adding new functionalities, you wanna add it to your API layer, because that is the one that calls through all your microservices. So you wanna make sure your API layer or interface, this is called, has the ability to talk to all your microservices and has that ability to handle any of the information that is coming in from the users and handle directing it to where it needs to go within your backend microservices. Finally, or not finally, but then we migrate what we took in the group component and we migrate it into a macro service. This basically means all of these modules accomplish a certain task. So we group them all together like we did. We look at what it is. For example, here you have equipment service, personal service, skills training management service. So say in like skills training management service, you have like a UI component that's related to skills management. You have code for the actual people in part of the training and management. You have code for like what the skills are. Macroservice is that in between from a monolith to a microservice because it can still be tightly coupled for different components that you can still further split out. And so from that macroservice, you can migrate it to a microservice. For example, if we took that training one, you can break it down further. You can segment out the UI component. The UI code could be its own microservice because it can be programmed in its own code language, its own framework, and it just makes sure it has that connection to the backend code that it needs to reference and show. And that backend code could be split out into its individual microservices, such as training module, user module, and so on and so forth. Just a quick visual of a simple monolith to microservice. So you have here a monolith of users, threads, and posts. So it's like a messaging website, and you have all of it in one monolithic structure. But when you migrate it over to microservice, you have a specific component for users, you have a specific component for threads, and you have a specific components for posts. And also if you're messaging service as a UI, another service for like the UI itself. So that way you can make changes and your UI won't break. But this is a very primitive example of monolith to microservices. This is at a very high level because it is a very advanced and deep topic. So if you guys want to have a talk about it a little bit more deep dive, let us know and we could probably make that happen. But for tonight, I just wanted to go over it at a very high level, and that's pretty much your quick guide to monolith to microservices. Thank you. Had the worst.
Thank you, thank you. Thank you. Now, microservice, thank you very much for calling. So next speaker is Michael.
Can you hear me if I do the thing? Can you hear me? Okay, this thing, yes, they can hear me. Back again, back again. All right. Mirror. No. All right. All right, are we ready? Okay, so I don't want to hold this. I got it behind me. Oh, yep, share the screen, got it. Share. And slideshow, and I give up. We're gonna have to do this as it is. Okay. Well, is it working? Yeah, okay. A program that omits needed synchronization might appear to work, passing its test and performing well for years, but it is still broken and may fail at any moment. And that's from the Java concurrency in practice. This is basically a breakdown of the first 3 chapters. That's what I want to do for this one. So one of the interesting parts about it, you can write your code in any order. It doesn't care. It doesn't care as long as it can reorder it in the thought of a single thread. That's a big, yeah, you nod your head, you're like, yeah, I had it. Compilers are allowed to reorder instructions in either thread when this does not affect the execution of that thread in isolation. It doesn't matter which order they do it. So you can actually end up with a couple of crazy things here. So you got R2 equals A and R1 equals B for thread 2, but they can be completely reversed. You can have any order as long as it makes sense from a single thread's point of view. Next, we're going to go into race conditions. The most common type of race condition is a check and act. I've done the, oh man, I forget what this pattern is called, but it's basically a lazy loader for an object, an expensive object. There's better ways to do this, like stack initializers. But one of the big points about this is that you look at something, you're like, okay, this is not good or it is good, and you look at it and you go and do the next step. Unfortunately, with this one, because there is no way to make sure the actual Java memory model will work, there is no guarantee that this object will be the same on the same thread. And that's the big thing about it. We've got this expensive object here. It could have taken 2 minutes or an hour to build, and one thread can see it and one can't. And a lot of it comes down to a lot of the performance optimization. If you look at this from the idea of like a network or any kind of CPU, you're going to look that a lot of this stuff has to do with caches and stacks and heaps. So one of the ways to fix this is with volatile. The volatile keyword ensures that updates are made to a variable and read written to the shared memory. So this is important because what you can end up with this one is 2 threads or 100 threads in different situations, and they won't know that the others made an update. And there is no guarantee that the Java will even care. It'll put it in just like saying, no, 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 you're good, you're good. You can have the old data. It's all done for performance. You could have gone with the synchronized keyword with this one. Unfortunately, by using the synchronized keyword and things like this, you've introduced a bottleneck. And that's something we want to kind of avoid if at all possible, because now we've got 100 threads. Only one thread can go in here at a time and check. It can only do it that way. At least with the volatile, we may not have the perfect mutual exclusion, but we do have visibility. Memory consistency. This is one of my favorite ones when you look at it. I put volatile boolean asleep right here. Without this volatile, you could have 2 threads, and this asleep doesn't actually have to change. It could just spin, spin, spin forever. And that's because, again, the actual Java memory model says that if it can cache it and you've not told it that it's on notice to be able to change, it'll keep it. So it'll put in its L1 cache, leave it there, and you will spin forever. And that's a fun bug to deal with. Again, trying to go fast with this. So we have starvation and live lock. Starvation is when you have like 100 threads and there's just one thread that sits out there and says, no, I need to be able to do something, guys. I need to do something, but you never give it. And a live lock is an interesting one. These are basically when you have 2 threads competing, or more threads. And what they're trying to do is get resources. And this is for resource contention. So when you make your program, if you have 2 locks, A and B, and they're done in different order. So thread 1 grabs lock A and thread 2 grabs lock B, and then they both need the opposite, you've created a live lock. And what happens is they cannot get out of it. They are stuck in there until they try and like break out of the cycle through other methods. Oop. Sorry, that was another one. Publishing problems. So there is no happens before guarantee here. This is one of my favorite examples from the book. It's an interesting one because if you look at Holder, and I almost said Hodor because I'm just a dork like that, but you can see that there's a private int in. This class itself is not a problem. But if you look right here, we could have n does not equal n. Like the editor I was using was like, no, this can't happen. But it can. You absolutely can have n does not equal n because of the memory model. It's the most ridiculous thing ever. And it all comes down to this one. This is a public holder. Sorry, I'm very funny. But it creates it. And what the problem is here is that we didn't make this final, we didn't make this volatile. So there's no guarantee that we won't have a half-baked step. What you can end up having is that the actual problem with this, as funny as it sounds, is the superclass of object will make this holder object, but it will do it in a 0 fashion. So you've got the default values. So n does not equals n. So it just ends up with that. I want to show this again. This is from the JLS to show it to you too. So you can see where they did final int x and int y. Again, if you look at here, you've got a reader and a writer. This is not a, immutable class. This is also not marked as final with the int. And so what you end up having is no guarantees for memory. When you look at the JLS for the memory model, you're going to look at a lot of things that say, this is happens before guarantee or happens after guarantee, and you don't have that. So now that you know there's kind of the problems, how do you safely publish things? Well, one of them is you can do a static initializer. It's always guaranteed to run before it goes through the class, and so you're guaranteed to have it. A volatile or atomic reference. An atomic reference is basically a volatile through an object and everything with it. A final field gives you like a happen before guarantee with it, and using locks to protect access to it. Okay? And that is this. I think I kept within the time on this one. Thank you. I want to bring up one more thing that really bothers me about Java, and that's the optional type. I hate the fact that we have an optional that can be null, and then I've seen it so many times as null. We have null safety, but it can be null, and it drives me insane. I had to bring that up because it bothers me. Thank you.
What do you need me to have? Yes. Like this. Zoom. We're gonna share screen, yeah? I'm gonna show my whole desktop. Should be simple. Good. Good. Are we good to go? We're good to go? All right, good evening. Huh? What's that? That's cool, thank you. All right, so listen, I'm Black, Country, and Church phrase. When you look at the Venn diagram of those three communication, we operate on the principle of call and response. What that means is when I say good evening, you say good evening. So let's try that one more time. Good evening. Good evening. This is an awesome full circle moment for me. I was actually here back in 2009. Part of my story is the fact that I'm a career transition person. I haven't been doing tech my whole life. Most of my life, I've been flipping burgers, making pizzas, talking to the mic, and things of that nature. So in 2009, I worked at Jackson State University, wonderful HBCU in Jackson, Mississippi. I ran the food court. When we went corporate, we got a Pizza Hut and I had to come here for training. So nice full circuit moment for me to now be here and not worried about pizzas anymore. So let's get started. My name is Lockhart, as you see. I'm a developer advocate for Vaadin. And tonight we're talking about making stunning web applications. When I say stunning, I'm talking about the front end, the back end, probably most importantly, the integration of those two. When I say web apps, we talk about web applications, websites. You probably think React, Angular, Vue, Next, right? JavaScript wars or JavaScript framework wars. And that's fine. But if you're a Java developer and that's who you are through and through, you probably don't care about those wars. You would like something made for you. We have something for you. Stay tuned. So first question is, what the hell is Vaadin? All right. Who has ever coded in Vaadin, even hello world level at all? Anybody at all? We got one. We have one. We have two, but he's like real tripping about it. Like, I don't know if they want to call out. All right. Have you ever heard of Vaadin before tonight? All right. Heard of. Cool. I'm glad I came. I'm in the right place. What the hell is Vaadin? There's a technical definition, but I like to think of Vaadin in the mic. They can hear me. Oh, this mic? They can hear me. You can't hear me. Stop lying. Anyway, I like to think of Vaadin as the bridge, the marriage between Java and modern web development. Modern. So modern web development, you might think of those frameworks, but it doesn't have to be that way. There is a way to use Java to do that. Now, for those who are old school Java, you might be thinking, oh crap, this is Java Swing all over again. It's not Java Swing, okay? Fun fact, Java Swing per Oracle has been eclipsed by Java FX, and Java FX does some cool things in the UI, but if you want to build a good, robust business application, you still need another technology on the back end. You might be thinking, okay, well, this is probably like GWT. GWT supported by Google, it's cool. It did some unique things back in the day, but of course it went from corporate support to community support. That's got some pluses and minuses to it. Still cool for fun projects, toy projects on the weekend, but if you're responsible for the architecture for a large enterprise, you probably want to know that there's another large enterprise on the other side that can support you. That's exactly what Vaadin is. Vaadin is a company, and we have some awesome solutions specifically designed for Java developers and Java teams. That's what we're here for. If your company is Python through and through, we ain't got nothing for you. I'm sorry. We're here for Java developers. We want to give you some tools to make your lives better. So within the platform called Vaadin, we have three solutions I'm talking about tonight, our components and two frameworks, one called Flow, one called Hilla. For the two people who have touched Vaadin before, Hilla used to be called Fusion like a long time ago, but don't worry about that. It is now called Hilla, which interestingly is the name of a berry found in Finland, Finland being the country where our company was founded and has corporate offices today. So I said web components. We have a robust set of web components, 50 or more web components that give you tons of building blocks to quickly build your UI. Think in terms of if you're a good old-fashioned old school Java dev, you have to build a dashboard because your boss said so or some internal tool. You really don't want to screw around with going in a deep dive in React. You just need to make the thing work. You need the grid, you need the date picker, you need the, we have you. We've got you covered. You can grab these out of the box. They work well. They are customizable if you want to get deep into the UI and throw some CSS on it and make it fancy, but otherwise they are ready to roll off the box. They work seamlessly with both of our frameworks. I don't like this mic. Both of our frameworks, or they work on other frameworks as well. So I said components and two frameworks, right? What's the first framework? Vaadin Flow. And all right, so those images are going to give me a headache. There we go. What the heck is Vaadin Flow? Vaadin Flow is full stack web development with just Java. Front, back, and all things in the middle. And in fact, one of the fellow developer advocates that works with me, Matti Tavonen, he actually looked at using Eclipse Store to persist data, and it's written in Java, which means theoretically you could have robust, real life enterprise level, full stack web apps with nothing but Java, which for many of us is our core language, is what we go to. For many people, it's not. We're not for them, we're for you. So that's what Flow is, full stack with one language. And look at the syntax, it's very familiar. In this case, we have a class called Hello World View. It's extending a horizontal layout. Horizontal layout is one of our components. It's how we're going to organize our UI components. We'll talk more about that later. We're initializing a couple of fields there. And if you look at it, those fields are actually components as well. So just under the constructor Hello World View, you see name is a new text field. We just made a text field just that easily. No HTML, no JavaScript, just Java. It's yes, breathe. It's just Java. Say hello, new button, say hello. We just made a button. Now, how do we actually add those to the page? Look all the way down to the bottom line. Add, name, comma, say hello. We just added those to the page. You want to beside each other, you put it inside a horizontal layout. You want them vertically, you put it in a vertical layout. Done. Done. What's next? More about Flow. My cursor's not working. There. In Flow, everything is a component. So think about every visual aspect of your UI. I really don't need the mic. That's why I'm kind of getting away from the mic. And I like to walk around. But anyway, every visual aspect is a component, whether it's a date picker, whether it's a button. So here is another easy example. I have a button, I'm calling it clicker. I have a date picker, I'm calling date picker. That is all the code needed to make this happen in the browser. This is real. This is not like fake. This is a screenshot. This is actually from a website, a button in the date picker, and we've got 50 of those for a wide variety of use cases with the most simple code imaginable. The name of your page, use an annotation, page title. To route it to the particular route, the URL, use an annotation at route. Value is about. A class, like you're familiar with Java, public class AutoView extends what? Vertical layout. So you know these two are going to be what? On top of each other. It's just that simple. More about Flow. The layout builds your views. So you take those UIs, those UI components, but you don't want them to float all over the place. You need organization. So you're going to use our layouts. Our layouts themselves are component. I mentioned the horizontal and the vertical. So in this case, this is a lot like the last example. So I'm going to breeze through this, but I do want you to look at again, making a new text field, making a new button. Don't worry about the middle for now. You skip to the button, you can add those two. So these two components on the right, those are two UI components organized in the UI layout. The other view on the left, that menu, that's in the vertical layout. The individual components are responsive and you can customize the layout patterns as well, if you like. Last slide about Flow. Vaadin Flow uses event-driven programming. In other words, think about it, JavaScript lives in the browser, so you kind of can't get away from it. What we've done is abstracted that away from you, taking that load off you. You're just going to code Java if you use Flow. There's another solution, but if you use Flow, you're just coding Java, which means when the user interacts with your UI element, Flow is going to send that message to the backend because we have Java, which is a server-driven language, a server-backed language. It's going to control the event listener. And what we've done is we've made the syntax look, if you're familiar with JavaScript, kind of JavaScript-like, but even easier. So in this case, watch this. We have, let's look at just the button. You see the say hello, you see the new button, say hello, say yes or no. There we go. That was like 6 people. Thank you. So that is a button. That is a component. How do we add an event listener to that button? We're going to use dot notation. Say hello, drop down to here. Say hello, dot add click shortcut. No, not that one. Oh, this one. Say hello, dot add click listener. When that event fires off, we're firing off a notification or whatever other sequence of events we want to happen. We just added an event listener to a UI. No JavaScript, none of that other stuff if you don't want to deal with that. If you do, we have another solution. Just hold on. But if you don't have to anymore. You now know about Vaadin Flow. Let me go to my IDE real quick, show some chord organization. There's 2 ways to start a Vaadin Flow project. Let's go here first. Oh, I hate that bar. Ugh. 2 ways to start a Vaadin Flow project. The first one is going to go to start.vaadin.com. I want you to do this tonight or tomorrow or the weekend. Just play with it. Just play and see. Was that guy just lying to us? Was he blowing smoke up my nostrils? Or is there some validity to this? Go to start.vaadin.com. Can I get rid of the bar? I don't like the bar. More. Thank you so much for that. God bless you. Thank you. So this is one way you can start a project. You can hit start project and get a nice GUI visual way of doing things if you like kind of drag and drop style. If you don't like that, no problem. You go down here, discard that, click on edit. And you have your choices. We can start a Vaadin project, flow project, or Hilla. Talk about Hilla in just a minute. In this case, I'm selecting Java. You can also select Kotlin. I'm selecting it as a Maven build because I'm a Maven kind of guy. And Spring Boot, hit download. I'm not going to do that. You have out of the box a Hello World level Vaadin flow project ready to roll. When you open it in your IDE, it will look like this. Those who are Spring Boot developers, Java developers, which is pretty much all of us, you'll recognize your source folder right here. Inside that source folder, you have your main folder, you have your Java folder, and you have your application class somewhere. Hold on. There it goes. And that'll be our entry point into this Java project as you're used to. Nothing weird, nothing too new. Watch this. This is kind of cool to me, and hopefully to you. So here's a service, a really simple service. It's called greet service. And we got a method called greet that does a little check here, and it's going to give us some return values. Here's what I want you to look at. This is a back-end method. This is in the back of the house, Java, server. How do we call that from the front traditionally? Don't answer, just think about it. How would you just call any method on the front end to make something happen in the browser? With Flow, that greet method right there, because it's already in Java and Flow is all Java, I can go to my view, which is also Java, and I call it exactly the way that it is. Nothing else to do. I just call it my backend method from the front. This is a simple example. It can go for any level of complexity that you like. That to me is pretty impressive. Clap for myself. All right. I was being facetious, y'all. It's cool. It's cool. It's cool. This was a quick demo. So this is an example of a lot of our components. And one of the ones that you can't really see, there's a button at the top right that says light or dark. Actually, you can see it. If you literally click on dark, it changes the entire thing from that look to that look, because the Vaadin Flow and Vaadin Hilla are based on the Lumo theme, L-U-M-O. It's a clean, sleek, business-like theme, controls the look of all of your applications. It is customizable if you want to dig down in the CSS and make it look the way you want to. But again, our use case where we excel is for data-rich, high processing business applications, internal tools, dashboards, that kind of thing. We rock at that. Nobody beats us with that, I promise you. A little bit about Hilla. So we finished with Flow. Put that to the left of your mind. We're going to deal with Hilla now. What if you just want to deal with your UI a little more? Maybe you came up on the HTML, CSS, JavaScript side of the world first, and you want your React. It's okay, we got you. If you're a Java developer, we got you. With the Hilla project or the Hilla framework, we combine a TypeScript front end and a Spring Boot backend and a single project. The start.vaadin.com, you can go there and start it, or you can use your command line that's npx @hilla/CLI init, name of the project, and you will get a full stack web app, Hello World level, out of the box, ready to roll. With a TypeScript front end for React, Spring Boot backend, ready to roll. But there's more to it. Remember earlier I said the studying has to do with the integration. We have, for lack of a better word, a ton of wiring on the back end to make communication between the front and back seamless, abstracted away a lot of the things that are so boring and laborious to do as a developer. Just pull that away where you can just code your Java, do whatever you want to do at the front, and things just work. For example, and this is, let's not see there. For example, calling Java methods. So it was really, really easy with Flow, right? It's just Java. But what about if you have I'd ever coded with a project that had React and Spring Boot on the back end? 1, 2 people in the entire building. What are y'all coding every day? Just kidding. So typically, if you want to call a method from your Spring Boot services on the front, what would you go to? Those 3 people, what would you use? Or other people who just don't like raising their hand, which I think is the case. What would you use? How do you do that? You call your API. So a REST service could work, GraphQL could work. You have a few options. They're kind of laborious. With REST service, what would you do? You would annotate your service with REST controller. Down on your method, you would annotate it get mapping. You would put your URL in there at get mapping /URL. Then on your React code, what would you do? You would have to fetch whatever you have to do to fetch that URL, pull it in, and then then response, then this, then that, catch the error. Then finally, down to that functional component, you'll return your TSX and you'll actually call the method. That's like a lot of work for no good reason. We say, why? We'll do that for you. Just use Hilla. So in this example, we have a couple of methods, one called find all, one called save. Focus on find all. This is Spring Boot. This is Java. You know this. You know this stuff. Look at find all method. All we're going to tell you to do is use the @browser callable annotation. That is a Hilla annotation. When you put that annotation on this Java service, Hilla says, oh, they need these methods on the front end. So I know what I'll do. I'll create TypeScript equivalents of everything here in a data precise way on the front end for you. So when now you don't get it initially, when you compile the code, as soon as Spring Boot and Hilla scans and sees that annotation, instantly a to-do endpoint.ts file will be created for you on the front end with all these same methods and all the data types intact. And so that's the bottom half, which means now no REST service, no GraphQL. When you want to call a backend method on the front, you just call it. And I know you can't see that crap. Hold on. Zoom plus Google Slides is interesting. Well, you can see the call. I wanted you to see the whole code, but basically all I'm doing is calling to-do endpoint, and that's the TypeScript to-do endpoint, because that's a TypeScript file, .tsx up front. To-do endpoint.findAll, which is calling it from TypeScript, is calling the exact same method down here. No questions about data safety, integrity, security, none of that. It's all abstracted away, taken for you. In fact, all of the classes annotated with browser callable on your back end, it will generate those TypeScript files in a generated folder. And we always tell you, don't touch the generated folder because we guarantee it's correct the way we do it. If you go trying to fix things, you're probably going to unfix things. So just don't touch the generated folder. It's grayed out for a reason. That's, for me, very impressive. I was like one of the first things I learned about Hilla. I love that. More about Hilla. In a similar manner, validation. So forms, data validation. All your validation rules in Java are reused by your form automatically out the box without you doing anything. And we're going to go to some code to talk about that real quick. So that is our flow example. I'm going to go ahead and open our Hilla example. I'm not going to do the code organization, kind of running out of time here, but just follow me real quick. So this is a Hilla project. When you run it in the CLI or that start.vaadin.com, this is how it will look. Essentially, I've only added 2 files here, only 2. Down here, source folder, you know what that is. That's your Spring Boot. This is your whole Spring Boot app right here. We have a services folder. You can add your data folder, your model folder, repository, everything you would normally do, you would put it down here. Watch this. In the services folder, I added a single class called attendee. Super simple. We got 2 fields, name and the email, and I know I'm going to use this in a form. So I'm going to throw my validation rules, my constraints on those 2 fields. Not blank for name, because how am I going to save your data? I don't know your name. And @email for email, because people like to be funny and put like Mickey Mouse. So that's my validation rules. All I have to do is put that on the Java object, and then make sure I have some service that is browser callable. Remember that one, which lets Hilla know, hey, they're going to need everything here on the front. And all I'm doing, I made a method called attendees. It's returning an empty list. The point is, the type of attendees is list attendee. That's my class. That's my Java class. It's a list of attendees. You're done. You're done. To make sure that form is correct on the front end, which we haven't even looked at yet, you're already done. So when we go to the front, is it in Hello World or about? Y'all give me just 2 seconds. Yes, it's in the Hello World. So this is now the front end. This is my React app. This is one project. We go up here, we're going to use our use form hook, this guy right here. That use form hook, which is going to pass that attendee model. It's going to return a model, which is the attendee model, auto-generated, don't touch that folder. Also returns this function, which is our field, which means we can use our spread operator on that field down here. This is like the ugliest form ever, but we can use our spread operator, and on that field, we're just going to say model name and field model email. You're done. It's going to validate that that data is coming in the way that you said you want it to be done on the back end. Let's see if, am I lying or not? Let's run the program. It's very bright. All right, so here we go. So here's our rinky-dink form with the user and email. Let's say we just wanted to skip that. I'm just going to tab through it. Boom, must not be blank. It works. That was a clap moment. Just kidding. So anyway, email. Like I said, Mickey Mouse. That's not an email. Let's try that. Please enter a valid email. I didn't do any extra work, any double work on the front end that's been abstracted away. You can look at it. This is all open source. You can go to our repos and see how it works in the back end. If you just need it out the box to happen right now, this is the solution for you if you're a Java developer or Java team. Back to our presentation. So again, I'm a developer advocate for Vaadin. You would expect me to think that this is like the bee's knees, best thing since unsliced bread or sliced bread. But what do people in the world think? Like regular Java developers and Spring developers and stuff like that. What do they think? Let's see. This guy whose name I can't pronounce, so I had to put it up here, Micheal Arsenault, had this to say on Twitter. I regularly complain about the lack of full stack frameworks for Java. Tons of stuff on the back end, Spring, struts, all kind of stuff, but second-class citizen when it comes to full stack. That is not true anymore. Check out Hilla Framework. We appreciate him for that. Anyone heard of Mache? No? All right. How about Sharat Chandler? Chander. Okay, this is like Mr. This is like Mr. Java. You got to know this guy. He is the director of developer experience for Oracle. Like he's Mr. Java in my book, beyond, you know, the inventor of Oracle, the inventor of Java. So he said, one of my favorite companies that plays an important role in Java technology adoption, give them a follow. The Vaadin team, this is our symbol, is top shelf. We appreciate him for that. You haven't heard of Sharat. How about Dan Vega? Anyone heard of Dan Vega? There we go. There's the head nods. So if that's Mr. Java, he's like Mr. Spring with his cohorts. And he said, and this was recent, this was December 15th, 2023. It took him all of 5 minutes to put this together. He loaded all of his blog posts in JSON and displayed them in a filter, I can add for him, a filterable, sortable grid in Vaadin Flow in 5 minutes, because he actually builds with our technology. A guy that works with him is Deshaun Carter. You might have heard of Deshaun. He said he's been using version 24 of Vaadin, which was in pre-release back then. He has to say he's a fan. I'm not going to read all that to you, but at the bottom you see it says, I like this pattern. 10 out of 10. None of these are paid sponsors. And last but not least, Simon Martinelli. We absolutely love that guy. He's been building with Vaadin for years. He is a tech founder. He is I'm not sure, is he a Java champion, but he's definitely a Vaadin champion multiple times over. And he posed a question, did you know that Photoshop Online was made with web components? Web components and lit. He thinks that web components are really the future of development. If you want to use them, you can do it with Java and Vaadin Flow, or you can do it with React and Hilla. And so we appreciate that. So what happens next? I want you all to play with this stuff. Anybody who needs a personal project, toy project, need to spin something up real quick, go to start.vaadin.com. You can do Flow or Hilla, or you can go to our GitHub repo. That's not a good place to start, but a good place to see what's happening like underneath the hood for those who like to get dirty. And certainly follow us on socials, LinkedIn and Vaadin, LinkedIn and Twitter. By the way, you can't see it, but on Deshaun's next to last line, I'm trying to get the AOT processing to work. So our developer advocate team, we're lean and mean, but we're very efficient and we're just like everywhere. So literally within minutes of him saying that, my boss was the VP of DevRel. He was writing the comments and gave him like a whole repo and solution to fix this thing, because that's how we operate. So we're out in socials, we're integrating with people, and we're trying to help your lives as a Java developer be a little better. Thank you.
All right, thank you, Lawrence. One more applause for Lawrence.
Now it's audible? Yeah. Nice. Hope it's visible. Yeah, and audible. First of all, thanks for getting here. Thanks for having me. Before I start, I really wanted to appreciate the efforts of Danny, Dennis, Eric, and team. As a marketing guy myself, it's I know it's pretty difficult to organize, arrange, execute a meetup like this. So it's pretty impressive work. So yeah, first a huge round of applause for these guys, right? Thank you. So I had a ton of code I wanted to show, but I'm gonna skip that. I see we are already past the time. So I'm gonna, instead of going in the code aspects, I'm gonna go on the skill set. So I'm gonna talk about testing and specifically testing at scale. So first question here, who all are doing automation testing or even manual testing here right now? I know Chris, you're not listening. I was talking about it. So yeah, so before I get started, a little bit about me. I'm Mudit. I'm one of the founding team members at LambdaTest, currently heading the marketing and product side of LambdaTest. So I'm going to pitch in a little bit about LambdaTest as well. So it's a little bit different. And let's put the presents over here. I'm also going to try to link what we all learned here so far with what we are building at LambdaTest. So let's talk about first why, as a Java developer or as a developer in general, you should care about testing, basically automation testing in general. Right? So this is something that I've come across multiple times. And this is a completely separate skill set that there are dedicated SDETs or software developers, engineering tests whose job is to write code, but it's not something for me. I'm a developer. I don't need to know or need to write a code. But though it starts thinking in some ways are correct, but in practicality, when we talk about it, how the company or how the global big companies are working, that's usually not right. So we wanted to validate that proposition. So during our test week conference here at LambdaTest, again, free open source conference that you can attend, we did a survey on quality assurance. We had responses from around 1,600 plus teams across different countries. And one thing we found out is that writing automation tests is something that is not only dedicated to SDEX or in some places not dedicated to developers. There was a time when everybody was talking about that developers should write their own tests, then panned out. Truthfully, right now, what happens is nearly it's a very collaborative effort. Both devs and QAs write the tests, manage everything. It's a pipeline, it's a process. So if you are an automation tester, awesome, you should need to learn how to develop, how the application is built up. If you are a developer, in the other way around, you also need to learn how the automation testing is being done, how the testing process happens. So that's what I'm going to touch base a little bit about today. Right? So let's start off with, we are talking about Java. So if you are starting with Java-based applications or no Java and want to start off with Java-based testing, there are a ton of frameworks that can help out. Selenium, Playwright, JUnit, TestNG, SVN, there are like nearly 35 different frameworks that you can choose from. And usually, though I'm saying here frameworks and I'm talking about TestNG a little bit, I'm not that much into frameworks. It's more about it's another tool that can get the job done. So you have to check what application you are testing, how you are testing it, what things you want to achieve. And based on that, pick a framework that you like best. So for example, if you ask any Java-based experience automation tester, there's a huge debate on JUnit versus TestNG. I personally like TestNG, but that does not mean that's the best framework. So yeah, good place to start out is start with Selenium, start with Playwright, good frameworks, then pick up a layer over the top, like TestNG or maybe JUnit 5. So why I personally like TestNG is because it has ton of features built in. If I start from scratch with any one framework, I have to add in a lot of coding aspects, a lot of layers over the top to make everything work together. But a good part about a framework is a lot of things is already baked in, a lot of things is already built in. So TestNG has a lot of things baked in. My best parts is running tests in parallel. Why we need that? I'll get to that part, and of course reporting. Another thing I forgot to add over here is there is a ton of support specifically in Java ecosystem on over the top of frameworks like TestNG, even JUnit 5. You can add in a lot of plugins specifically for reporting, specifically for adding more and more type of tasks that you want to accomplish. That's one of the great aspects. So usually in developer community, people talk about the NPM repository, but in Java we have Maven repository, right? So that's MVN repositories. That's the same thing. So you have a ton of support over there. And if you want to start off with TestNG, one of the frameworks, that's where you can start off. Just download the repo, start working with that. The best, so again, I wanted to highlight, I wanted to go very deep into the coding aspect. I have the whole TestNG, everything set up in IDE, but it's gonna take a lot of time. So I'm gonna just take a screenshot, took the screenshot, highlighted the most important aspects. So first of all, of course, you have to ensure all the dependencies are there. I'm using Selenium as well, so I've added Selenium dependencies. The best part about TestNG framework is that you can define the overall test execution structure. So what should happen before the test starts, what should happen when the test is starting, and what should happen after the test is done. So validation aspects of it. So in my case, I'm browser doing a very simple test of opening up Google website, verifying that the title is right or wrong, and then I don't think I just terminating the browser. So very, very basic test again. You can make it as complex as possible. Okay, so if you want to get started with this, we have a Github repo that you guys can leverage. Just download, it's plug and play. You can run it pretty easily across. And in our GitHub repos, LambdaTest, you will find more different type of frameworks as well. JUnit, JUnit 5. If you are JavaScript based, so a lot of framework support over there as well. So yeah, even Cypress, Playwright, everything is there. Running your first test, so I took a screenshot, added that whole test base here in the IDE. Running that screenshot again is pretty easy as well. Another good part about TestNG and Java-based ecosystem is they are very tightly integrated with your IDEs as well. So I've just done a very simple integration of TestNG repository with my Eclipse IDE, and they are able to find it pretty easily. Debug TestNG test very easily there as well. Another good aspect about a framework like TestNG is they have a lot of inbuilt mechanisms specifically for reporting. So testing is as good as you get the results out of it. What is fast? What is failing? What was the result out of it? How much time it took? So all of those actionable insights. So as an automation tester, that's another skill set you need to learn, how to look at the reports and get the insights out of it. So in that survey that I mentioned earlier, we got to find out that automation testers only spend 17% of their time writing the code. Rest of the time is either spent on debugging or collecting reports, making reports, sending that across. So shit ton of work happens just without coding aspects. So that's there. Another aspect is, so this is very basic report. You can use a plugin like Surefire, add over the top, and kind of get more detailed insights, more detailed reports as well. But there are some limitations as well. So that's what we here at LambdaTest, we are also helping that out. Another good aspect about TestNG is they have built-in parallelization. Well, what do we mean by parallelization? So as an automation tester, now we wrote one test earlier, right? But you have a big application. There's a lot of workflows. So that means there are a lot of tests. First, if you have, let's say, 100 tests, and if you run that across sequentially one by one, each test take a minute to complete, your overall whole test execution is going to take 100 minutes. So what's the best practice? Instead of running tests sequentially, you distribute it across different machines, run it in parallel to each other. So if you are running, let's say, those 100 tests across 10 machines, or running them in 10 parallel, the overall test execution comes down by a factor of 10. So instead of 100 minutes, now the developer feedback time is cut down to 10 minutes. As a developer, that's a very important aspect. Developer feedback time. That means you have done, you have just made something, clicked on commit. Now you CI/CD or a GitHub repo. What happens is there are automated tests that triggers, And once those tests are passed or complete, only then you get to understand whether whatever you have built up is right or wrong. So that particular time period where you have to wait for the whole testing to complete is pretty important. That developer feedback time has to be pretty fast. And specifically for a big enterprise company where they have, let's say each commit has triggers hundreds of thousands of tests, that's become a very big problem. So coming back to TestNG, right? So another feature about TestNG is it has built-in features. There's a TestNG.xml file that you can use to very minutely orchestrate what test has to be done, what test has to be done where, how you want to organize this test, how you want to club those tests. So it's kind of like a bin packing algorithm. You have multiple tests that have to be packed across multiple trucks that have to be sent across multiple routes. So that whole logistics, managing that becomes pretty easy with a framework like TestNG. But it's not just about the framework itself, right? So let's talk about what happens when you are running these tests at a larger scale. I talked about hundreds of tests. What happens is when we are at hundreds of thousands of tests. So this is a movement, again, I'll say shift left movement. Most of you have either heard about it. If you are not heard about it, what shift left means is people are kind of working towards running tests as early as possible. So earlier stage, there used to be a proper stage in the whole development life cycle. Like this is the point when we want to run tests. We design, we develop, and now we run the test. But through automation testing, because of automation testing and because of tooling, CI/CD based toolings, we are able to trigger tests earlier. So now, and whenever it came down to whenever any single build is being built, you want to run tests. But people said, why only when we are running build? Why not earlier? So anytime now a developer hits a commit, let's talk about in an enterprise scale. Every time 50 different developers hit a commit in the repo, 50 different times a series of tests have been done. So that's running tests early. And that's also a good thing, right? Because even at the commit stage, you are able to understand how the application is working. So at a very early stage, you are able to find defects. At a very early stage, you are able to remediate those defects. And if you guys have practically seen it, then the fixing bugs at a very later stage is a very, very painful process. So you're fixing it early, that's pretty good. So coming back to skill sets, we understood as a Java developer, we need to first learn how to run automation tests, then run those automation tests at scale using parallelization. The next step is CI/CD. Nearly 88% of the companies, small or big, are using some kind of CI/CD tooling. If they are not, they're gonna pretty soon adapt to it. So there is no other way about it. Both developers and testers right now are adding stuff to CI/CD platforms. So if you are not aware about them, I think there should be another skill set that we should add. Specifically platforms like Jenkins, Circle CI, GitHub Actions, Azure DevOps, GitLab, all of these are pretty good options. As a Java developer working across open source, I would suggest that Jenkins is a pretty good option as well. Good skill set to have. And one of the best part is, so right now we all talked about IDEs. So what that means is I'm running tests on my local machine. But in a practical cloud environment, that's not a very right way to do. So best way is run those tests at cloud itself. And best part is use a CI/CD platform that is deployed over cloud, use some kind of runner like this, and run that across. So GitHub Actions, for example, comes with inbuilt baked features that help you. For example, here I'm setting up the environment using the JDK. I'm also setting up other type of artifacts that I want to pull in. I'm running across on a Ubuntu Linux machine. So just add in everything, set up a GitHub action, pull my code in and run. It's pretty easy, pretty basic thing to do. But yeah, it's another skill set to have. But in this part, I'm touching upon one of the very most important aspects, that is infrastructure, or what we call environments. Why is that important? That is important because you have, let's say, a web application that you have built up, or a mobile application that you have built up. You want to ensure that it is working perfectly across all browsers, all operating systems, all browser versions, all mobile devices. 17 mobile devices, Samsung launches every day, 6 mobile devices, Apple launches every day. Every other month, a new Chrome version gets launched. Every other month, a new Firefox version gets launched. You have to ensure your application is working perfectly across them. So the permutations and combinations of those testing starts to increase. So earlier I have those 100 tests. Now imagine those 100 tests have to be run across 100 different type of machines, 100 different type of browsers, 100 different type of mobile devices. So complexity starts to scale up, and infrastructure became one of the biggest problems. And of course, as you have more and more set of tests, as I said, it's not scaling up linearly, it's kind of scaling up exponentially. So high test execution time, which became a problem, helped in developer feedback, it's kind of cut down the developer feedback time. And most importantly, flaky tests. So let me know, anybody here who knows what flaky tests are? 2, 3, 4 people? Oh, a lot of people here. So more than that. So flaky tests are ghost tests. Like they were working perfectly someday, but today without any reason they are breaking. We have not done any change in the code. We have not done any change in the testing code, and still if they are breaking, or maybe they are giving false positive results. So those are flaky tests. They are pretty difficult to debug, very difficult to find as well. But usually they are in a very less percentage of a number. So let's say 1% of tests are flaky tests. But if you're running hundreds of thousands of tests, that 1% becomes a very big number. So at scale, because of infrastructure, a lot of these problems comes. And that's where I want to pitch my product. That is LambdaTest. So what we do is we provide an online cloud infrastructure that can be leveraged to run any type of test at any type of browsers, operating system, browser version, and can be used to run any type of scripts. Java TestNG I talked about, you can use it to run Cypress, Puppeteer, Playwright, any type of script that you have. And the best part is all the browser versions, mobile devices that we talked about, we have collected that for you. We have put that on cloud, and now you can run your test across all of those. So that whole DevOps team that is required to manage, spin up machines, manage infrastructure, organize everything, that's all on us. We do that as a product. So we just have to use our APIs, throw the test across, and everything works. So the permutation and combinations I talked about, it's 3,000. Sometimes it goes to 30,000 if we talk about the browser versions, and we have all of that. To start off with, just it's free to sign up. When you sign up, you get an access key and you get a username. And the earlier TestNG tests that we were showing, to run those across a LambdaTest, you just need to make it 3 changes. So instead of running at local driver, you run it at a remote web driver. And for remote web driver, you need to pass on an authentication key and let us know what browser version you want to run your test on. And that's it. So the same test that you already have, to run that across a LambdaTest, that becomes even easier. So just few lines of changes. This is how our dashboard looks like. So this is another thing we have built over the top is. So now you, every time you run a test, you get screenshots, you get complete recordings, you get complete logs, both system logs and console logs and your IDE logs, everything baked into together. And the best part is because you are able to run these tests in parallel. So you do not have to worry about one machine. You can run it across 100 or even 1,000 different machines at the same time, cut down your developer execution times. There's nearly 1 hour whole system of features that we have baked in. But I'm going to talk about this last feature. This is something that is pretty unique and pretty new aspects. Most of the things that I've talked about is automation testing that has been done there. Some enterprises are doing it, but this is the new thing that is happening. So test orchestration, what does that mean? Earlier, we talked about that I have a set of automation tests, I have machines, I have thrown those tests across those machines and started to work. But in that first come, first serve or a brute force test execution mechanism, that also not very efficient as well. So you need a smarter way to properly distribute those tests across different machines, properly distribute those tests across different dependencies, gather different dependencies across for proper test execution, and that is what test orchestration is about. So if you are an advanced automation tester, I think this is the next skill set that you guys need to have. We as a LambdaTest, we have built in a lot of these features over the top that can help you out. But these things can also be done using CI/CD tooling. A lot of AI-based efforts that is happening is also happening in this regard, how the smart test orchestration is being done. So we talked about continuous testing, but what's next? So this is what we call smart continuous testing. We have automation tests. People have been doing it for 10 years. We have continuous testing, shift left. People have been doing that for 5 years. Now we want to make it more efficient. So, and the best part about this is like the most important aspect about all of this is the reporting aspects. So get everything together, orchestrate everything together, and get the best reports out. So here at LambdaTest, to do all of that we highlighted earlier, there's just a simple YAML file that you have to add. But again, as I highlighted, not gonna go into code part more. For us, the feature parts, we talked about Automation Cloud, but we also have testing features. So if you need browser or device to spin up very fast, just use a platform from us, and we'll help you with that. So manual testing as well. Again, huge set of features we have built up so far. We have been building LambdaTest for 5 years now, so not going to go into detail around that. So yeah, that's my set. Feel free to reach out to me over LinkedIn, email, Twitter. I think this goes to my LinkedIn, so feel free to reach back to me. I'll be here around for a few more minutes. If you want to know more about LambdaTest, what we do, or just want to chat more about automation testing, I'm here. Yeah, thank you.
Give a round of applause here from Dick. Without further ado, Trey.
Thank you. Fantastic. Before we get started, thank you all for being here. It's kind of past my bedtime. My computer's at 20%, so I'll make this quick for us. Before we start, what I would like for everyone to do is just stand up where you are. Even if you're virtual, please stand up. Cool. So we're just gonna hold up our right hand like this. Cool. Hold up your left hand. Right hand comes down. Left hand comes down. Right hand comes back up. Cool. While that right hand is up, look to the person next to you and give them a high five, please. Love it. Okay, cool. You can sit back down now. And if you're virtual, here's your high five. There you go. There we go. Okay. So, my name is Trey Clark. I am the computer science teacher at Emerson High School in Frisco ISD. Yeah, go maps. Where we teach all the way from like what is a variable all the way to unabstracting abstract data structures. So if you would like to follow along your own personal devices, here's a QR code. And if you don't like the QR code, there is a bit.ly that you can type in right there. So I'll give you about 10 seconds to do so. And I'm going to pull out my timer to keep myself true to let's see, thumbs down. Okay, today we're going to talk about creating a backend using Java. Now, we heard earlier Lawrence talked about Vaadin, which I think is amazing. We're going to sort of take that apart and use just the backend. So we're not really worried about the full stack part here, but just the backend. So on the agenda today, we're going to talk about, well, what is backend development, right? So we're getting to the really nitty-gritty of it. Why should I choose Spring Boot for my backend development? We're going to get some coding examples, and they're also going to see a demo app that I had to make this past week. And then after this is finished, going to prosper with the information that you have. So what is backend development? It is simply refers to the process of building and maintaining the server side of a web application or software. It involves creating logic, all that fancy stuff that the user does not see
So when you go to a website, everything they see the pictures, the buttons, everything like that is considered the front end. Everything they don't see, so the logic, the user authentication, the database management, the whole architecture is going to be the back end. And we can use Java in this particular case to actually build that out. So some parts of the backend, like I just mentioned, some of the server-side logic, what does that mean? Well, just handling tasks such as data processing and user authentication, and just some other like business logic, essentially. API development, so how do we talk to the front end, database management, and also different site or security-based things. I'm not going to read all of that, but if you have the slide, you can go and look through there. So as some dad said somewhere, use the right tool for the job, not vice versa. If you laughed at that, fantastic. If you didn't laugh at it, I promise I'm funny. I do have some jokes, and talk to me afterwards. So what are some tools of the trade? So we see right here, and I just added this Vaadin because again, I do think it's really cool. So if based on what we're trying to do, we have to have the right tool to do the thing. So if I'm trying to develop some microservices, I might use Amazon Web Services. If I'm trying to build a full stack Java application, I might use Vaadin. If I'm trying to build just the backend, specifically an API using Java, what am I going to use? Spring Boot. So what is Spring Boot? I'm not going to read that, but we can break that down into 4 sentences. 2 actually. 1, 2, 1. Spring Boot is an open source Java-based framework used to create standalone production-grade Spring-based applications with minimal setup and configuration. That's the key word there, minimal setup and configuration. We can get a project, we can hit run, and it works. So, what can Spring Boot offer you? A lot of things. One of the biggest things is like, even though it's an older technology, it's still in demand. I actually saw a post from Danny earlier this week where he was talking about, someone had mentioned that you shouldn't learn Java because it's an older technology. Well, just a quick LinkedIn search, I typed in Java developer, and just in the US alone, over 400,000 hits. So the Java technology is still in demand. Being able to build the backend using Java is still in demand. So this is something that's worth looking into. Again, also comes with auto configurations, API development, built-in security, enhanced memory allocation. So we're not well, yeah, we'll just leave it there. And some other things there. And what I really like is there's so many different development tools that you can use. One of the cool things that I found was you can have an in-memory database. So you don't actually have to build out a database, but you can just sort of store it temporarily and do your SQL queries or whatever database you're using in there. So those are some things that Spring Boot can offer you. So how do we actually start a Spring Boot project? Well, the first thing we're going to do is we're going to navigate to this URL. There you have a whole bunch of clicky buttons that you can use to configure your project. Afterwards, you download the demo, you open it in your favorite IDE, and then you build. Cool, so before we get into that, we're just gonna look at some code examples and what this actually looks like. So before we talked about some annotations, so you see this like @ sign here? That's basically an abstraction of something that's happening at a lot lower level. So what we see here sort of working from top to bottom is this REST controller is enabling this class of user controller to essentially do CRUD operations. So we're doing those GET requests, we're doing those PUT requests, deletes, updates, all of that stuff. And it's happening right here in this repository. The repository, as David said earlier, is a subclass of the CRUD repository because that's going to be our superclass, again, which enable us to do those CRUD operations. And then we see here I have a GET mapping to test. And so what this is going to do is actually going to run this method here and just return hello world. Once I go to wherever this application is hosted, go to /users/test. So once I go there, we return hello world. And we'll see that here in a second. And now a little bit more of a more complicated method here. So same idea, we have this request mapping here, which is kind of like the overarching sort of endpoint there. This particular one is going to add a restaurant to a database. So we see here this repository, this repository here is the database that we're interacting with. And this get restaurant by name and zip code is essentially a method that translates down to a SQL query that Spring Boot does for you. So you don't have to write the SQL query. You just type out the method given the conventions, and it creates that SQL query for you. So then you can get whatever or come up with those special queries. And then once we do that, we have this optional here, which can return null. If something isn't that optional, then the restaurant already exists and we don't want to add it to our database. If it doesn't, then we're going to save it in our database, and then we print out the appropriate HTTP status, which is it's been created, and it handles that for us too. So we don't have to remember what does 401 do, what does 402 do, what does 500 do, because we have that all stored inside of these properties essentially, okay? So the demo. So once you move this bar, cool. So we go to the Spring initialization website, so start.spring.io, and we see here sort of the configuration stuff. What language do we want to use? How do we want to serve the project? What version or whatever. I just default to Maven using Java. I've been using, actually been using 3.2.2, but I guess that's new. And then what is the name? And then you can actually install the dependencies or lists of dependencies here. So if I wanted to have my project use a SQL database, I would type in SQL driver, and there I go. One of the cool ones that I use is called Lombok, which is an annotation library. And typically when we write Java classes, we have all of our PIVs in the constructor, and we have to have setter and getter methods. Well, you don't have to, but you should have those. Well, anyways, it's a pain in the butt to write all of that stuff. So all we have to do is have an @getter or @setter, and it writes all of that stuff for you. So Lombok is one of my go-to dependencies there. Once we do that, we click generate, and then it downloads the file right there. Boom, I now have my project. So then from there, what I'm going to do is I'm actually going to open just one that I had earlier. We see we have all of our sort of like files already ready to go. And then I can hit start, and then it runs my project. So to get our hello world, what I'm actually going to do, I've already written it out just to save us some time, is we'll just make a new file, new Java file here, and we see that I have now this class hello is a REST controller. So I'm able to then do some sort of CRUD operation on this class. So I have a get mapping here at path hello. So whenever I go to my localhost /hello, it should return the word hello, or should return hello world. So I'm going to run this, and we see some ASCII art and everything down here. Cool. So we see here I'm running on 8080. So I'm going to open up my terminal. I'm going to use curl here to fetch localhost 8080/hello. And then we see we got the string hello world. Cool. So then on your front end, all you would do would be to talk to that endpoint, and you'd get the same thing back. Cool. So now for more, I guess, scalable, I use that term very loosely here, application. I essentially, to demonstrate this, made a sort of Yelp clone. So what we have here is the first thing, we have the table, so the restaurant table. What are the PIVs? What are the columns on that table? We can notate those like here. And you see, this is all I have in this class. Because before I mentioned that those dependencies from Lombok, because if I have my getter and setter dependencies, it automatically creates those getters and setter methods for me so that I don't have to do it. So we're cutting down on development time, which is pretty handy. From there, I have my repository. So generally, you can like find by name, find by ID, things like that. But whenever you want to create more complicated SQL queries, you can create an abstract method. Abstract means we don't build it out here, but we build it out in the class that we're using it itself to do that. So get restaurant by name and zip code, which takes in a name and a zip code, and then returns back the list or returns an optional. So it's looking for one restaurant. This one returns a list of restaurants, so on and so forth. And then so the file itself that's going to handle all of that stuff, we see here that I'm using a REST controller. So then my restaurant controller is now able to do those CRUD operations. For my first one here, we see /all just returns all of the restaurants in the database. How do we add one? Well, we pass in a JSON that's been stringified of that information, and then we add that to the database here. If it already exists, then we don't add it, and we pull back or we send back an HTTP status code that says it's already in there, and so on and so forth. We can have modular routes with here, so we're using parameters. So if I did restaurant/4, it would give me a restaurant. If I did restaurant/5, it would give me whatever ID that is. Because that's what these curly braces do. They make it a little bit more modular, and then I can return and find by their particular ID. Okay. Spring Boot really utilizes the MVC pattern, so model view controller, and this is what this demonstrates. Now, while we can use this on the front end, is this should be open. Cool. So using TypeScript, I would not suggest doing this. You should definitely put all of your security things and environment variables. So I just have here just a simple fetch, and what am I doing? And then I can call that endpoint. I've deployed my my Spring Boot application to Railway because it is a standalone app, and that's also where the database is also hosted. So then I come here, oops, to this website. Hopefully it looks good up there. Okay, great. So we see here all of these restaurants are in the database itself, including, so like these, not even PNGs, but like the ratings, the name, the genres, it's all there. And then so I can see here genres. This is going to call one of those custom queries. Well, so get all the restaurants based on their genre. So I'm going to click on American. And then we get all of the restaurants that have the American genre. So we can see there's 5 of them. We're just going to look at the first 2. So I get all this information back from the database as well. And now we see some reviews. So this particular one has 5 reviews, and this is the first review. Again, I'm using that Spring Boot, calling that endpoint, and then getting that information back. So I click View, and then we see this one has reviews. My cat wrote a couple of them. If I click write review here, I'm just gonna go, we'll do that, and then I'll say hi again, and then submit, get a little message there, refresh, and then scroll down, and now it's in my database. Because I hit that endpoint, I sent that JSON, sent it to the database, and now I pulled it back. Cool. So essentially, that is Spring Boot in a nutshell, and that's how we can use it on the front, or use it in a full stack application. So I want to thank you for listening to me. If you'd like to connect, here's a QR code for that. If not, then that makes me very sad, but I see a lot of phones out, so that's a good thing. So thank you all again for listening to me.
Thanks everyone for coming. Again, we're gonna do a quick photo. Everyone wants to come up to the front. So see your beautiful faces. And then for the Zoom, go ahead and turn your camera on. Can you actually do your
Oh yeah.
plug in for a bit?
Yeah.
So people want-
Of course.
All right, stay on. We're taking that photo. You can see yourselves on the screen there already. Thanks so much for staying on. Chris, of course, you're on screen, my man. Thanks for joining, everybody. We'll see you next time.